Hi learners, welcome to my YouTube channel. Today we are going to do the part 3 of the topic playing with numbers. We have already done some of the questions from this topic. So now let us start with the remaining ones. So here they said check whether the following numbers are divisible by 10 or not. So one of the way to remember if it is divisible by 10 means always you will see whenever you multiply by 10, that is the 10 times table. So everywhere you see the ones places, or we can also call it as a units place, that is 0. So here this is one of the simple way whenever it is divisible by 10. So you will see at this one, so this is not, this is yes, this is not, this is not, this is yes, and this is yes. So the next one, check whether the following numbers are divisible by 4 or not. So here what you have to do, either you have to see the divisibility rules, or you can directly divide. If you don't know the divisibility rule, you can directly divide it by 4 and see whether the number is divisible or not. How can you see? Like whenever you divide a number, the remainder should be 0. If you're not getting a 0, that means it's not divisible by that number. So you can check by any of the ways. Either use the divisibility rule or directly divide and check by 4. So here, check whether the following numbers are divisible by 9 or not. Same over here, you can either use the divisibility rule of 9, or you can check directly and then decide whether it's divisible or not. And Y stands for yes and N stands for no. Again here, divisible by 5 or not. But here what we can do here, divisibility of 5 is very easy, because the ones place is going to be either 5 or it is going to be 0. So 0 or 5. So let us see the ones place. This is not, this is yes, this is not, this is yes, this is yes, and this also is yes. Now check whether the following numbers are divisible by 11 or not. So here both, anything you can use the divisibility rule of 11, or again you can check it by dividing by 11, and if the remainder is 0, that means it is divisible. So you can check, the answers are given over here. Now again for 7 and 8. So here we have to check for both. You have to divide by 7 and you have to divide by 8 and see whether if both of them are divisible, then only you have to write yes, otherwise you have to write no. Here, which greatest digit should replace m so that the number, this is divisible by 3. So here in place of this m, we have to see how that is. What do you get over here, the number? So what you have to do, first thing you will add 7 plus 7 plus 8 plus m plus 0 plus 9. So now when you add this, you get 31 plus m. So now see, whenever there's a divisible by 3 means this is 31 actually. The other number which will be divisible means it is going to be 33, because divisible by 3. So it should be either 33 means, because here you will get 3. So see, when we do this one, 33, when we rearrange this, m is 33 minus 31, that is m is going to be 2. They have asked for the greatest number. Again, when we do for 36, that is going to be 5. 39, if we take 39, that will be 39 minus this is going to be 8. And if we take 42, 42 is going to be 42 minus 31 is going to be 11, but that is a 2-digit number. So the greatest number can be only 8. So we can put the greatest digit that when added to 31, which makes the sum divisible by 3 is 8. So m is going to be 8. Hope you got this one. What are the possible digits that can be filled in the box, in this box? So it is divisible by 6. So now here, let us see here. Let us put this as x. So for a number to be divisible by 6, it needs to be divisible by both. This is the rule, that by 2 and 3. So what will we do? Again, we'll add all these numbers. This is what I have added over here. So 24 plus x, that will be, if we take this number, because this is 24, if we take a 24 itself, 24 minus 24, if we rearrange this one, 24 minus 24, that is going to be 0. Then if we are taking 24, then again we'll take 27. If we take 27, you are going to get 3. Again, if we take 30, we are going to keep on adding 3 to it. 27, 30, then you get 6. Then again you will add 3, you get 9. So what we can say here that when this x will be 0, 3, 6, then it is divisible by 3. Can you see here? This is 0, this is 3, this is 6, and this should be here 9. Then it is divisible by 3. So 0, 6 and 3, 6 and 9 are the possible digits that can be filled with in the box. So later on you can also check these numbers. You just divide and see this one by putting these numbers and whether it is divisible by 2 and it is divisible by both of them. Later that is to recheck. Which digits should be filled in the box so that this number is given is divisible by 33. So now again here we'll put as x. So here to be divisible by 33 by 2, if a number is divisible by 2 co-prime numbers, then it is divisible by their products. So this is the rule. So now what will you do here? You will add all these numbers. Here in place of this you will put x. So what do you get? 22 plus x. So 22 plus x means after that whatever it is divisible by this, if you put here 2, that is 24, here 27, here 30. So here what will you get? You will get here 2. When you rearrange this, you will get 5. When we rearrange this, you will get 8. So they ask for the which digit should be filled in the box. So this one, it is divisible by 33. So we can say 2, 5 and 8. So now when you add this ones here, 1 plus 4 plus 3 plus 7. Suppose now see here, here whenever there is a rule. So 1 plus 4 plus 3 plus 7 at the odd places. These are the odd places. See here, can you see these numbers? 1 plus 4 plus 3 plus 7, the odd places. And these are the even places. So even this one, that will be 1 plus x plus 6. That will be 7 plus x. So now the difference when we see here, so odd places means 15 minus this will be 7 plus x. So what do you get? 8 minus x. So now difference is 0, means 8 minus x is 0. So x is going to be 8. And when x is equal, so what we'll say, when x is equal to 8, then it is divisible by 11. So you have to see the rule, what is given, and according to that, you have to solve this one. So this is that sum of the digits at odd place and sum of the digits at even place. So when it is, which digit should be filled in the box so that it is divisible by 33. So the next one, it says that determine if 27,468 is divisible by 63. So again here what will you do? You will apply the rule that if the number is divisible by 2 co-prime numbers, then it is also divisible by the product. So last digit is given here, that is 8. So twice here, the rule for this is twice the last digit is equal to 2 into 8, that is going to be 16. So remaining number, what will be that here? 2746. So this, after that, the remaining number is 2746 because we have taken the twice the last digit, as that will be twice of it, that is going to be 16. So you will take the difference of that, difference of this number, the remaining one, minus this the twice, that will be 16. That's why it will be 2730. And now this is going to be what it is, which is divisible by 7. So therefore we can say 27468 is divisible by 7. So again, what will you do? Sum of its digits will take. So we got here this one. So 2 plus 7 plus 4 plus 6 plus 8. So that is 27. And that is divisible by 9. So therefore, we can say 2746 is divisible 9, since 27,460 is divisible by 2 co-prime numbers, that is 7 and 9. because you know that the difference should be 2. So the 7 and 9 should be the number. Therefore, 2746 is also divisible by the product, that is 63. Na? So 63 means 7 nines are 63. So they said divisible by 63. So these are the numbers that is confirmed. 7 nines are 63. Show the prime factorization of the following numbers using the factor tree. So now you know the factor tree means what will you do here? First thing, what you always, whenever to find the factors means we are going to multiply by, start with 2. If not by 3, then 4 and so on. So here this is 72. This is we are going to do. They have asked with the help of the factor tree. So 2 times this will be either you write your multiplication or just write here 2 and 36. That will be 72. Again, what will you get here? Again, this will be left as it is because you cannot do anything over here. So 36 will be 2 times 18. So again this will be left as it is. So here will be what? 2 times 9. Again this will be left as it is because you cannot do anything here. 3 times 9, and this also will be as it is. So what do you get here? This whatever you get, 2, 2, 2, 3 and 3. These are the factors of 72. So you can write here. See, now can you see here? This I have written in this way as well. 2 into 36. Then 2 into 2, you will take here 2 into 18. Then again what will you take? This 2 into 18 into 2 into 9. So 3 times 2 and 9. And the last one you have to include this as well. So finally what is that? These are the factors of it. 2, 2, 2, 3 and 3. 2, 2, 2, 3 and 3. And you can multiply and see. 2 2s are 4. 4 2s are 8. 8 3s are 24. And 24 3s are 72. That means whatever we are done is right. 108 will take the factors with the help of the factor tree. You will write here 2 and 54. Again, you will write here 2 and here 27 multiply by this one, 3 and 9. So you don't have to jump with the higher number. You have to go with the lowest number. Then again here 3 and 3. So what is remaining here? 2, 2, 3, 3 and 3. So this is the last one. And you can again check it. 2 2s are 4, 4 3s are 12, 12 3s are 36 and 36 3s are 108. So again for here, this will be 2 and 80. So again here, 80 will be 2 and 40, 2 and 20, 20 will be 2 and 10, and this is going to be 2 and 5. So these are the factors. This is what is written over here. So 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, and 32 5s are, that will be 160. Again, the same over here, you can check it. Everything is given over here, and it is the same method. You can see for that. And these are the factors, what is here. Same for here. Now this is actually the number is bigger, but we cannot do anything over here. We have to start from 5, and this will be because see with 3 it's not possible. So we can only go with 5 and 61. Then 61 is a prime number. So we have to stop at this one. So 5 into 61, that is 305. Again here that is the same. You can have a look at it. These are the factors. Now here what did they say? That was with the help of the factor tree. Now this is with the help of the prime factorization. So prime factorization with the using the short division method. So this is the short division method. So 148 means again here you are going to start with the lowest number. Start with 2, if not by 3, 4 and so on. We don't have to jump for the bigger number. So this into this will be 148. This into this is going to be 74. This into this will be 37, and 37 is a prime number, so we cannot do further anything. So whatever you get over here, these are the factors. So 144 is 2 into 2 into 37, and then you can multiply and see 2 2s are 4 and 37, that will be 148. Again for here same, this into this, this into this, this into this, 23 is the prime number. So these are the factors of it. So this is written over here. 338, same over here, you can check with this one. 496, again the same. So same over here. And 31 is a prime number, so we cannot do further anything. So these are all the factors. So what is here? Again for 500, same. So these are all the factors of it. 696. And we cannot do anything over here. So these are the factors. I haven't written the factors here, but you can also write in the same way that 696 is equal to 2 into 2 into 2 into 3 into 29. That you can write it over here. So these factors write the prime factorization of the greatest three-digit number. So which is the greatest three-digit number? You know that is 999. After that, what will be there? That is 1000. So the greatest three-digit number is 99. And directly they haven't given the number, but they said you have to find the prime factor. This is the prime factorization. So 999. So you will do the same way, but you have to decide what is that three-digit number. And here, 37 is left as it is. Why? Because it's a prime number, so we cannot factor it. So this is the answer. Now complete the following prime factorization. So this is very easy. Now 235. So 5 into what comes to, for that you have to decide. So now see here in this one what you can do. This is the blank. So 235 divided by 5. So 5 times 4 and this is 35. So 5 sevens are 35. The remainder should be 0. So here whatever you get is quotient, that is you are going to multiply by 47. Now here there are many blanks. So what will you do for 396? You will write your 396 and you are going to take the prime factorization in this way, that is 2 ones are here, because it was only a single number we did it directly, otherwise and the blank was only 1. So directly just by dividing we could have done. Otherwise, even if you take a prime factorization of here, so it is going to be the same. Okay, so you try for that one and whatever you will get something here 47. Okay, and now for 396 same here. 2 ones are, 2 nines are, 2 eights are, 2 nines are, 2 nines are. That will be 3 threes are 33 and 3 elevens are and 11 ones are. So can you see 2 2 3 3 and one more 11. 2 2 3 3 and one more 11. 11 ones are 11. Again for here you will take the prime factorization for 462 and see what will be in the blank. 495 you will see the same and you will put that thing in the blank. Prime factorization. Now check whether the following prime factorizations are correct or not. So now see here, it's given here 294 is this one. So we have to check whether with actual, when we are doing the calculation, do we get this or not. So now when you do the this prime factorization with the actual calculation, so what do you get here? 2, 3, 7 and 7. So you get 2 times 7 and here they have written 11. So that means what we have to say, they said check whether the following are correct or not. The prime factorization of 294 should be 2, 3, 7 and 7 and not 2, 3, 7 and 11. So this will be the answer. Okay. Now again, they have given the factors this one and we have to check by the actual this one. So now can you see here? When you start here, because this one is not possible by 3. Because see 455, if I am doing by 3, 3 ones are 3, then 15, 3 fives are 15, but the remaining is 5. So this is not possible by 3, only possible by 5. 5 and then 5 this one and then 7 and 13. So you can check with it and they have given here 3. So they said the prime factorization should be this one and not this. Again here you can check and see. So what do we get? 2, 2, 3, 7 and 11. So this is the same 2, 2, 3, 7 and 11. So both are same. So the representation is correct. Same now look for here. You got 557 and here this is 357. So that is not correct. Now here the complete the following factor tree. So here here was a blank, here was a blank and here and this was given. So 21 times 2 is 42. Again here that are the only factors for 21 will be 3 and 7. So you will write a 3 and 7. So these are you have to complete a tree. Now for this one, was given, this was a blank, this was a blank, this was a blank, and these two blanks means 210 into 2. That is 420. Again 210, this was given means 37s are 210. Again for this one, 15 was given, so 15 twos are 30. And for this one, both of them only the possibility of these factors are 3 and 5. So these are 3 and 5. Now check whether the first number is a factor of the second number or not. So now see here, this is given first and this is second number. So what you have to do, first thing you have to divide by or 506 by 4. So the step 2, if the result is a whole number with no remainder, then 4 is a factor. If of course, whenever there is the remainder is 0, that is with no remainder means the remainder should be 0, then it will be a factor. So now let us check for years. See here, when we divide it, we get the remainder as 2. So now what did this say? Since remainder is not equal to 0, therefore it is not a factor. This is very easy. Again, now you will look for this one, 7 and 781. So now again you will divide and see the remainder is 4. So therefore it's not a factor. Again for this one, yes, here we can see the remainder is 0. So we can say since remainder is equal to 0, so therefore it is a factor. Again here when you divide this and this one, so the remainder is 0. So therefore it is a factor. For this one, the remainder is 2. Therefore it is not a factor. These things we have to write. Here the remainder is 0. So it is a factor. Here the remainder is not 0. So it is not a factor. So again, see, these are the big numbers. So you have to see, this is a semicolon and this is a comma for this one, 4,284. So you have to be very careful at this number. This is just a semicolon, means this is just a one number and this is the other number. So here the remainder is 0. So therefore it is a factor. So by this one, we have completed today's work. Do like and subscribe to my channel so you get a notification of the other parts. Thank you.